good day to all of you. In this video, we are going to learn the inverse Laplace transform. Okay, as you have learned that the Laplace transform for ft is equal to fs, the inverse Laplace transform is actually denoted by this symbol inverse power negative, fs equal to ft. Means is given the fs, we want to get back the ft. So this is denoted as an inverse Laplace transform. Next, okay, this is a symbol for Laplace transform for ft, we get fs. Okay. Inverse Laplace transform is actually given fs, we are going to get back the ft. Okay, we need the inverse Laplace transform. For example, we take the Laplace transform of on the first and second order differential equations, and then okay, the result will be in terms of the fs. To get the solution, we need to inverse it back, inverse the fs, then we get back the solution in the original function, in the original parameter, which is the t, which is the function of ft. Okay, for example, recall back our 7/6 Laplace transform formula. We have the Laplace transform for A is equal to AS, where the S must be greater than 0. Hence, the inverse Laplace of A over S, you will get back A. Okay, the second Laplace transform formula, the Laplace transform for t power n is equal to n factorial over s to the power of n plus 1 for positive integer n value. Hence, the inverse Laplace of n factorial over sn plus 1, you get back t power n. Okay. The third formula, as you know, that Laplace transform for exponent at is equal to 1 over s minus a. Hence, the inverse Laplace of 1 over s minus a will be equal to exponent at. The fourth formula, the Laplace transform for sin at is equal to a over s squared plus a squared. Hence, the inverse Laplace of a over s squared plus a squared will be equal back to sin at. The fifth Laplace transform for cos at is equal to s over s squared plus a squared. Hence, inverse Laplace of s over s squared plus a squared is equal to cos at. Okay, number 6, Laplace transform for sin or hyperbolic sin at is equal to a over s squared minus a squared. Hence, the inverse Laplace of a over s squared minus a squared is equal back to the hyperbolic sin at. Number 7, Laplace transform for hyperbolic cos at is equal to s over s squared minus a squared. Hence, the inverse Laplace of s over s squared minus a squared is equal to back to hyperbolic cos at. Okay. For example, inverse Laplace transform of 4 over s, you get back 4. Inverse Laplace of 1 over s minus 2, you get back exponent 2t. Inverse Laplace of s over s squared plus 25. Okay, 25 here is a pi squared, and this is s. We get back this is cos 5t. Inverse Laplace of 12 over s squared minus 9. S squared minus 9. Okay, notice 9 here is a 3 squared. 3 squared. So numerator you must have. Okay, you can write 12 here. You can write as a 4 times 3. 4 times 3. So notice that inverse Laplace of 3 over s squared minus 3 squared is actually hyperbolic sin 3t. So hence we have here 4, because 12 here, we factor as 4 times 3. 3 over s squared minus 9, the inverse is the inverse Laplace of sin 3t. Okay, inverse Laplace of 1 over s to the power of 5. Okay, you notice that s to the power of 5. Okay, in order to get the result of this inverse Laplace, you will get t power 4 So numerator you must have 4 factorial, which is 24. In 4 factorial you got 4 factorial is 4 times 3 times 2 times 1 times 2 times 1. So okay, which is okay, 24. So you multiply by 24, you have to divide by 24. And this is in the form of inverse Laplace of 4 factorial divided by s to the power 5, means s power 4 plus 1. You get this is t power 4, t power 4. That's why the inverse Laplace of 1 over s to the power 5 is t power 4 divided by 24. Okay, inverse Laplace of 1 over s squared plus 7. Okay, notice that 7 here can be rewritten as 7 is actually third 7 squared. Third 7 squared. Okay, if you have third 7 squared, okay, your numerator you must have third 7. So you have in the form of inverse Laplace of s squared plus a squared. So you multiply third 7, you have to divide by third 7. Then inverse Laplace of third 7 over s squared plus third 7 squared is actually you get back your sin a. The a is actually third 7. So sin third 7 t divided by third 7. And then as you know, Laplace transform follow the linearity property, and hence the inverse Laplace also follow the linearity property, which states that if alpha, beta are some scalar, and then the inverse Laplace for alpha fs plus minus beta gs, since they are some scalar, you can factor out, so become the alpha time of inverse Laplace of fs. Linearity means the operation here is plus minus, then you can break the symbol of the inverse Laplace and also your Laplace transform. And since beta is a scalar, you also can factor outside of the symbol of the inverse Laplace, and this becomes plus minus beta time of inverse Laplace of gs. Inverse Laplace of fs you get ft, inverse Laplace of gs you get gt. So this is so-called the linearity property. For example 1, inverse Laplace of negative 2s plus 6 over s squared plus 4. Denotes that your numerator you have 2 terms, then we can break it using linearity property. Becomes inverse Laplace of negative 2s over s squared plus 4 plus inverse Laplace of 6 over s squared plus 4. Notice that this is 4 and this is actually s. Then you factor out negative 2, it becomes the inverse Laplace of s over s squared plus 4 is actually the cos 2t. And s squared plus 4, numerator is constant, so 6 here, you will write it as 3, 3 times 2. So you have 3 times inverse Laplace of 2 over s squared plus 4. You will get 2 over s squared plus 4. The inverse Laplace is actually sin 2t. So this is the result. The second one, the inverse Laplace of 2s plus 5 over s squared minus 4. Again, so breaks the numerator, become 2, 2 functions. So you have inverse Laplace of 2s over s squared minus 4 plus inverse Laplace of 5 over s squared minus 4. And then factor out 2. So 2 times inverse Laplace of s over s squared minus 4. I will get this is hyperbolic cos 2t. And then this is 5 over s squared minus 4. If here is 4, means the numerator you must have 2. You factor out 5 here. And 5 already factor out. You notice that inverse Laplace of 2 over s squared minus 4 is actually hyperbolic sinh of 2t. So So you have 5 hyperbolic sinh 2t. You multiply by 2, you have to divide by 2. That's why the answer is 5 over 2 hyperbolic sinh 2t for the second term. And then the first shifting property, recall back the Laplace transform for ft is equal to fs, then the inverse Laplace for fs will be equal to ft, means inverse, reversing from right to left. Okay, and then recall back the first shift property, which states that Laplace transform for exponent at ft is fs minus a, then okay, the inverse means from right to left. So the inverse Laplace of fs minus a will get back the result exponent at ft. Okay, example 1. Inverse Laplace of 7 over s plus 2 cubed. S plus 2 cubed. Okay, so s plus 2 is actually, you can rewritten as, can rewrite as s minus negative 2 power cube. So this is in the form of fs minus negative 2. In the form of fs minus negative 2, by using the inverse Laplace of the first shift property, inverse Laplace of fs minus a, you have exponent at ft. By the a in this case is negative 2, so you get the result to be exponent negative 2t ft. So yeah, exponent negative 2t ft. To get ft is actually, you take the inverse Laplace of fs. Fs means your s plus 2 here, you make change the s plus 2, you replace it as a s. So it becomes 7 over s cubed. 7 over s cubed. Okay, and then we notice that s cubed, okay, if you have s cubed, the numerator, you make it as 2. So the inverse Laplace of 2 over s cubed, you will get t squared here. So if you multiply by 2, you have to divide by 2, and the 7 here will be factor outside of the symbol of Laplace transform. That's why you have 7 inverse Laplace of 2 multiplied by 2, you divide by 2, because the inverse Laplace of 2 over s cubed, you get back t squared. So lastly, the result is 7 over 2 exponent negative 2t, okay, exponent negative 2t t squared. Okay, so you notice, I repeat, okay, you notice that, okay, from the table of Laplace transform, impossible you see you have the s, let's say you have s, you have the, okay, you've got actually the s cube, I mean the s cube come from this term. Okay, s cube is actually, and from the table of Laplace transform, you notice that you have s cube is actually 2 plus 1, 2 plus 1. Hence, you must have 2 factorial, 2 factorial, 2 factorial. Mean you have a 2 factorial is 2, so this is a s cube. So the inverse Laplace will be t squared. However, you couldn't see that you have any, let's say, s plus 2. All the fs here is only s, only s. We don't have the s minus something. So that's why you need this is in the form of fs minus s plus 2 is actually in the form of the s minus negative 2. Mean we use back the first shift property. Okay, it's in the form of fs minus a, where the a is negative 2. Hence, the inverse Laplace will get exponent negative 2t ft. So that's why the result come up with here. We have exponent negative 2t. Okay, to get ft is inverse Laplace of your fs. Fs, okay, s plus 2, you just take back s. So 7 over s cubed. Okay, to get 7 over s cubed, when you see s cubed, numerator must have 2, so that you get this one is your t squared. So 7 factor outside of the Laplace, inverse Laplace symbol, 7 here. You multiply by 2, you divide by 2. That's why total your answer is 7 over 2 exponent negative 2t t squared. Okay, the second example, inverse Laplace of 3s over s plus 1, okay, bracket s plus 1 power 4. Again, okay, this is in the form of inverse Laplace of fs minus negative 1. When the result should have exponent negative t ft. Exponent negative t ft because inverse Laplace of fs minus a. Result is exponent a t ft, where the a in this case is negative 1. Okay. And then if you have the function fs minus negative 1, s is your s plus 1. So numerator must be also s plus 1. In order because this is actually, the whole thing is a function of fs minus negative 1. So denominator you have s plus 1, power 4. Numerator you must have s plus 1. Okay, the s you must change it to s plus 1. Okay, so if 3 times s plus 1 is actually, when you expand in, this is 3s, is correct. So you extra 3. Extra 3, that's why you need to minus 3. Okay, so now here and here actually tally 3s plus 3 minus 3, you get back 3s. Then you break this one using linearity property. It's the inverse Laplace of 3 times s plus 1 divided by s plus 1 power 4. So power 1 and power 4 you simplify, so it becomes 3 over s plus 1 power 3 minus, okay, then you break this one to another one, minus 3 is the 3 times inverse Laplace of, okay, or minus inverse Laplace of 3 over s plus 1 power 4. So both terms are actually in the form of inverse Laplace of fs minus negative 1, and the result should be exponent negative t ft. Okay, so to get ft is actually inverse Laplace of your fs. Okay, so from here your result you should have carry on the term exponent negative t ft. To get ft you must do the inverse Laplace of your fs. Okay, fs means s plus 1, just make it become s. So inverse Laplace of 3 over s cubed. So same thing here, exponent negative t, inverse Laplace of 3 over s to the power of 4. Okay, and then you notice s power 3. Numerator you must have 2, so that the inverse Laplace of 2 over s cubed you get t squared. So you multiply by 2, you have to divide by 2 so that it is balanced. So the 3 in the initial numerator you factor out, so you got 3 exponent negative t divide by 2 because you multiply by 2, so that you can get the inverse Laplace of 2 over s cubed is t squared. So for the first term total is 3 over 2. Okay, here t squared exponent negative t. Okay, for the second term, when you see s power 4, s power 4. Okay, s power 4, look here, s power 4, so mean the n is 3. So you must have 3 factorial. 3 factorial is actually 6. 3 factorial is 6. Hence, you multiply by 6, you have to, okay, mean you have here, s power 4 is actually, s power 4 is s 3 plus 1, and this is a 3 factorial, which is equal to 6. Okay, so you multiply by 6, you have to divide by 6, and 3 here, you factor outside of the symbol of inverse Laplace. So 3 exponent negative t divide by 6 because you multiply by 6. And the inverse Laplace of 6 over s to the power of 4, you get t cubed. This one you get t cubed. Okay, and then this one you simplify, 3 over 6 is actually half. So you get half t cubed exponent negative t. Okay, and the third example, the inverse Laplace of 6 over s plus 1 squared plus 4. Again, okay, s plus 1 squared, okay. So this s plus 1 squared is actually, you have in the form of inverse Laplace of fs minus negative 1. The result should be exponent negative t ft. That's what you have here. From the s plus 1 squared, you get back the term exponent negative t by using first shift property. And then to get the ft is actually inverse Laplace of your fs. Fs means 6. So s plus 1, replace it, become so s squared plus 4. Okay, so inverse Laplace of 6 over s squared plus 4. Okay, you see this is 4 is 2 squared. Numerator you must have 2. 4 is 2 squared. 2 squared numerator you must have 2. So initially we have 6. So mean 6 you break it become 3 times 2. 3 times 2. And the inverse Laplace of 2 over s squared plus 4, it becomes your sin 2t. That's why the result is 3 exponent negative t sin 2t. So with this case, thank you for your attention and watching this video.